Problem number 18 asks us to divide by a fraction. Dividing by a fraction is the same as multiplying by its reciprocal. By reciprocal, we mean we turn the second fraction upside down. If you look at the example to the right, you see that 2 divided by 2/3 is the same thing as 2 times the second fraction turned upside down to make it 3/2. So in our problem, we have 5/9 divided by 18/25. So we'll do the same thing. So we have 5/9. We'll say 5/9 times, and the second fraction flipped is going to be 25 over 18. Do you remember how to multiply fractions? Well, you multiply the tops together, 5 times 25, and you multiply the bottoms together to get 9 times 18. Now, as the case when you have fractions, you need to reduce if you can. When we try to reduce, we'll see the only number that goes into 5 is 5. 5 does not divide evenly into 9 or 18. The only numbers that divide into 25 are 5 and 25. Neither one of those divide evenly into 9 or 18. So we see this cannot be reduced. So it's time to multiply it out. Let's multiply 5 times 25. So we'll get 5 times 5 is 25, carry 2. 5 times 2 is 10, and 2 is 12. So the numerator is 125, and the denominator 9 times 18. So 8 times 9 is 72. We'll carry the 7. 9 times 1 is 9, plus 7 is 16. So our denominator is 162, and 125 over 162 is our final answer. Problem 19 is a word problem. Now, when you're given a word problem, it's very important to read it carefully to make sure you understand it properly. And equally important, you need to make sure you understand what they're asking, and that's what you answer. So we see Jake is buying some fruit. He buys strawberries. He buys 6 pounds of strawberries at $1.49 a pound, and he buys some blueberries, 9 pounds at 83 cents a pound. And then the question that's being asked here is, what change does he get back? What is his change when he gives the cashier 2 $10 bills? So to figure out the change, we need to know what we're giving the cashier, and we see we're giving the cashier here 2 $10 bills, and we need to know what the purchase costs. Well, they told us that because we see that Jake is buying 6 pounds of strawberries at $1.49 a pound, and 9 pounds of blueberries at 83 cents a pound. So, how do we figure out how much money Jake spent? Let's do the strawberries first. I'll abbreviate this as straw. So 6 pounds at $1.49. How much money is that? That's right, you have to multiply. If each pound is $1.49 and he bought 6 pounds, the total price will be found by multiplying those two numbers together. So let's do that. Let's do that over here on the side. 149 times 6. 6 times 9 is 54. Carry 5. 6 times 4 is 24, and 5 is 29. 6 times 1 is 6, and 2 is 8. And we have 2 decimal positions here. So the final answer must have 2 decimal positions. So we'll move the decimal over 2 to the left here, and the price will be $8.94. Let's do the same for the blueberries. 9 pounds at 83 cents per pound. That total cost will be found by, once again, multiplying the numbers together. 0.83 is the dollar, is the cost, 83 cents. 2 decimal positions times 9 for 9 pounds. 9 times 3 is 27, carry 2. 9 times 8 is 72, and 2, 74, carry 7. 9 times 0 is 0, plus 7 is 7. And we have 2 decimal positions. So this turns out to be $7.47. So we now know how much he spent in total by adding the cost of the strawberries to the cost of the blueberries. So 4 and 7 is 1, carry 1. 9 and 1 is 10, and 4 is 14. Carry 1. 1 and 8 is 9, and 7 is 16. So the total cost is $16.41 total cost. Remember, when you add or subtract decimal numbers, you must align the decimal numbers. So that's our cost. So we know our change is going to equal, well, the amount we gave the cashier. So amount given minus the cost. We'll give the cashier an amount. What she'll give back to us is the change, everything other than what the cost was. So let's plug in. Amount given is 2 $10 bills. Well, we know that has to be $20. So we'll plug that in here, $20 minus our cost of $16.41. Now it's easier for most people when they subtract to do it vertically, so I'll do that over here. $20, and we need the dollars and cents here because the $16.41 has cents, and we'll subtract, and we'll have a lot of borrowing to do. So we cannot take 0, take away 1. We have to go all the way out to the 2 here. So here we go. 2 becomes 1, then a little 1 here. We still cannot do our subtraction, so this time we have 10. So that will be reduced by 1 to make it 9, and we put the 1 here. Still cannot do it. The 10 gets reduced by 1 to be 9. And now we put a little 1 there. Now we have 10. So that we can do. 10 minus 1 is 9. Whoops. 10 minus 1 is 9. 9 minus 4 is 5. 9 minus 6 is 3. And 1 minus 1 is just 0. So our total, so our change is $3.59. And that is the final answer. Problem number 20 is another word problem. So once again, let's begin by reading it and making sure we understand what it's saying. They want you to find the cost of carpeting a room. So they're going to have to give us some kind of cost information. And they're going to have to give us how big the room is. And they do both. So find the cost of carpeting a room. It's 37 feet by 24 feet. So let's draw. Whenever you can make a problem visual, for most people, it makes it a lot easier. So we have 37 feet in one direction, and the other direction is 24 feet. And they tell you that the cost is $3 per square foot. So they're basing the cost on the amount of square feet. Do you remember what square feet relate to? Square feet relate to area. Square units in general relate to area. So you need to know the formula for a rectangle, the area. And that is area equals the length times the width. So in this case, the area is going to be 37 feet times 24 feet. This will give us the amount of square feet we have, and then we'll know what the total cost is. So let's go over here on the side. Let's do 37 times 24. 7 times 4 is 28, carry 2. 4 times 3 is 12, and 2 is 14. We'll get rid of that little 2, so we don't get confused when we multiply by the 2 now. We'll indent one column. 2 times 7 is 14, carry 1. 2 times 3 is 6, and 1 more is 7. Total it up, 8, 8, 8. So we get 888. Now here you have feet times feet. So that's going to be feet to the second power. And you pronounce that as square feet. So you can write it either in this way, or you can write the area with the word square. I'll abbreviate here, 888 square feet. But now we know that the size of our room is 888 square feet. Each square foot, we're told, is $3. So to figure out the total cost, we're going to have to multiply. So 888 times 3. 3 times 8 is 24, carry 2. 3 times 8 is 24, carry 2 is 26, carry 2. And 3 times 8 is 24, and another 2 is 26. So the total cost is $2,664. Problem number 21 is a percent word problem. We learned about these in problems 8 through 12, and the method we decided to use for any percent word problem that you would encounter is this formula, the power. We call it powering it up, P times W equals R. So let's read the problem and make sure we read it with understanding. 15 out of 24 students are absent. What percentage of students is present? So we see here they tell us information about students absent, but they want information, they want an answer about students present. So we're going to have to be careful here. Okay, we learned earlier that when it says percentage of something, it's always meaning the percentage of the whole. Just to refresh your memory, in this formula, P is percent, W is the whole, R is the result. So we're going to have to find percentage, that's P, and they say what percentage of students is present. So this is referring, in this example, this P here is referring to the students present. because that's what they want. We learned that P and R must agree, so this is going to be the amount of students present. So they told us that the total number of students in the class is 24, so that will be the whole. And if we specify 15 for R, if that's what we do, we'll be placing R with 15, but 15 is the amount of students absent. That's not what we want. We need to specify here the number of students present. Well, if there are 24 students in all, and 15 of them are absent, then we can determine how many are present simply by subtracting. So if we do 24, take away the absence, which are number of students absent 15, then we're left with, let's see, 4 take away 5, you cannot do that, so we'll borrow, and we'll get 14 take away 5 is 9. So therefore, the number of students present turns out to be 9. So that's what we're going to plug in over here. We're going to plug in 9. And now we solve. We'll divide both sides by 24. The 24s cancel out, and you're left with P equals 9 over 24. Now, you can do a long division here because you need to get a percent, and on the way to the percent you need to have a decimal which you convert to a percent. But I highly recommend that before you do that long division, you reduce. Do you see what's in 9 that's in 24? 3. So 3 into 9 goes 3, and 3 into 24 goes 8. 3 and 8 are much smaller numbers. That's why I recommend you reduce first. So we'll do 8 into 3 for our long division. I don't know how many zeros I need, so I'll put a few. And now we'll put the decimal point in the answer right above this decimal point, and we'll divide. 8 into 30 is 3. 3 times 8 is 24. Subtract, you get 6. Bring down the next digit, and begin again. 8 into 60, 7. 7 times 8, 56. Subtract, bring down the next digit. Begin again. 8 into 40 is 5. 5 times 8 is 40. So we're done. We have no remainder. So P equals 0.375, which needs to be expressed as a percent. And the way you do that is by moving the decimal 2 to the right. So the final answer is going to be 37.5%. A suggestion I make to my students is to, when possible, when it's not too difficult, look at your answer and see whether it's reasonable. They're asking me what percentage of students is present. A percentage is a part. We see it can be expressed as a fraction. It can be expressed as a decimal. So they want to know the students present represent what part, what percentage of all students. Well, does it make sense we got an answer less than 50%? What would be 50%? How many students would have to be present for the answer to have been 50%? Well, we know that would be half of the students. So if 12 students were present, our answer would have had to be 50%. So since we only have 9 students present, our answer has to be a little less than 50%. So our answer is reasonable. Problem number 22, both parts A and B, ask you to convert a fraction to a decimal and then round. If you want more specific information than I'm going to give in this problem, I've already taught this in questions 5 through 7. So to convert a fraction to a decimal, you're going to have to perform a long division. So we'll do that. Now I will add 1 0 here. This is the tens column, 1 to the right of the decimal. And to know whether I need to round whatever is going to go up here, I need to look at the next column. So I'll have 2 zeros here. And I'll line up the decimal point. 11 to the 50 is 4. 4 times 11 is 44. Subtract to get 6. Bring down the 0. 11 into 60 is 5. 5 times 11 is 55. 60 take away 55 is 5. Now I don't have to go any further than this because they asked me to round to the nearest tenth. So the tenths column is this column right here. This is the round off column. And since the column immediately to the right of the round off digit, since this is greater than or equal to 5, I will have to round up. So 0.4 becomes 0.5. And that is the final answer. Part B is done the same way, only this time we have the nearest hundredth, and the nearest hundredth is going to be 2 places to the right. So 13 into 8. I need 2 decimal places for hundredths, and then 1 more place to determine whether I need to round the result up. 13 into 80. Now, you might not know 13, but some of you might know 12. You know there'd be, 6 12s or 72, so let's try 6 for this. So 6 times 3 is 18. Put down the 8, carry 1. 6 times 1 is 6, plus 1 is 7. And for those who have difficulty or are error prone, you just can write on the side over here 13 times 6 to get your 78. You don't want to be careless. So we subtract, we get 2. Bring down the 0. 13 into 20 is 1. 13. Subtract 7. So now we have 0.61. So 1 is the hundredth. Now we just need to see whether we're going to have to round up. And it looks like we're not going to have to, because when we bring down the 0 here, whoops, we are going to have to, because you'll see that there are 5 13s in 70, because 5 times 13, 5 times 3 is 15. Carry 1. 5 times 1 is 5, plus 1 is 6. So 65 is not too large. So our final answer is going to be, well, to the nearest hundredth, it's 0.61. Once again, we see that the this over here is greater than or equal to 5, so I have to round up. So 0.61 is going to become 0.62, and that is the final answer. Just a note here, we wrote 0.62 here. which means we left out the whole part of the number. Well, there's no whole part at 0. So it doesn't matter how you write it. You can write it as 0.62, or you can write it as 0.62. No one really cares. As far as the exam goes, you'll only see one of these choices. You cannot have two correct choices. And the same would go for the previous part A. You could have 0.5 as your answer, or 0.5. Problem 23, part A, B, and C, asks you to reduce. Now, essentially, reducing is looking for common factors. Those are numbers that are being multiplied to give you the numerator and the denominator. When we see that we have common factors, we cross them out. The resulting fraction has the same value, but it looks different in that the numbers are smaller. We saw earlier when we were finding the LCM that we had to find an equivalent fraction. For instance, let's say we started out with 1/2 and the LCM was found to be 4. So then we asked ourselves, what do we have to multiply the denominator by to get 4? And we said that would be 2. And since we did that in the denominator, we have to do that in the numerator as well. And we came up with our answer of 2. Now, reducing is essentially going in the reverse direction. Now, reducing reverses this process. We want to take the 2/4 and go back to 1/2. So we start with the 2/4, and we know that it came from smaller numbers that were then multiplied by the same number. So we want to figure out what is common in 2 and 4. What is the common factor such that we got 2/4? So we see that 2 is a factor of 2. So we write 1 times 2. And we see that 2 is also a factor of 4. So we write 2 times 2 again. And we know that we can cross out. And we get 1/2. So that is how reducing works. You have to find the common factor or factors, if any, and cross out. Not every fraction can be reduced. Let's start with part A, 42/78. Are there factors that you see that are common to 42 and 78? Well, probably yes, because both numbers are even, and when both numbers are even, 2 is a factor. So let's rewrite 42 as 2 times something, and 78 will be 2 times something. So how do you find out the other thing? How do you find out the other number? Well, one way is you just recognize it. You're going to be dividing 2 into 4 into 2 into 2 to get 21. If you don't see it, you could go 2 into 42, and you get 21 that way. Same thing for 78. 2 into 78 is going to go 39. 2 into 7 is 3. 3 times 2 is 6. 18. 9 times 2 is 18. So we see 39. So the 2's cross out. And now the question is, are we done, or is there more work to be done? Well, at this point we have 21 over 39. Is there anything common to both? Well, we know 2 will not work now. Let's try 3. How do you know whether 3 works quickly? Well, we see in the divisibility table I have here that 3 works if the sum of the digits is divisible by 3. So 2 plus 1 is 3. Since 3 goes into 3, 3 will go into 21. 3 plus 9 is 12. Since 3 goes into 12, 3 will go into 39. So we can rewrite 21 as 3 times 7. And you can rewrite 39 as 3 times, let's see, 3 into 39. 3 into 3, 1. 3 into 9, 3. So that goes 13 times. The 3's cross out, and we're left with 7 over 13, and that is the final answer because the only number that goes into 7 besides 1 is 7, and 7 does not go into 13. Now, one of the advantages of using method 1 is that if you recognize common factors, you can get to the reduced fraction pretty quickly. The downside is that either you may not be able to recognize common factors, or you may stop prematurely. You may think you've found every common factor, whereas you haven't. So method 2 is called the prime factor method. Now, a prime number is a number whose only factors are itself and 1. So, for instance, is 5 prime? Well, what are the factors of 5? The only factors are 1 and 5, since those factors represent 1 and the number itself. 5 is prime. Is 7 prime? The answer once again is yes, since the only factors of 7 are 1 in itself. Is 9 prime? So don't fall into this trap now. You might think that every odd number is prime, but that's not the case here. So the answer is no, since 9 equals 3 times 3, and 3 is neither 1 nor 9. Okay, so now you know what a prime number is, and the way we use method 2 to reduce fractions is we find the prime factors of each number, of the numerator and the denominator, and everything that's common we cross out and we're done. And the best way to do this, or certainly one of the best ways to do this, to find the prime numbers of a number, is to use a factoring tree. You may have seen that already. So 42. Can you think of any numbers that multiply together to give you 42? You can do anything you want. Most people would say 7 works. 7 times 6. So I'll write 7, and over here I'll write 6. Now, my use of red here indicates that the number is prime, which means it cannot be broken down any further. 6, we know, can be broken down into 2 and 3. 2 and 3 are both prime, so we're done. So we can rewrite 42 over 78. We can write the 42 as 7 times 2 times 3. Let's try 78 now. 78. We know that 2 will work. And we saw before that 2 times 39 equals 78. We know 3 divides into 39 from the trick we learned that since 3 plus 9 equals 12, and 3 goes into 12, so 3 has to go into 39. So one factor of 39 will be 3, and the other will be 13. Both these numbers are prime, so we can rewrite 78 as 2 times 3 times 13. We see that the 2 is in the top and the bottoms, they get crossed out. We see 3 is on the top, 3 is in the bottom, it gets crossed out. So just like before, we see that the final answer is 7 over 13. So you can use either method whenever you want. You should certainly use the one you like better or feel more comfortable with. In general, this method too is used when the numbers are larger because it's more difficult to identify the various factors or get all the factors. Part B, since the numbers are larger, let's try method 2, or at least begin with method 2, the prime factor method. So we have 256. It's even, so we know it will have a factor of 2. Again, the red represents that it's prime. The other factor turns out to be 128. Now, if you don't see that, stop the video and divide 2 into 256, and you'll see it's 128. 128 we know is not prime because it's even. So 2 will be a factor of 128. Let's get the right color there. 2 will be a factor of 128. And 2 goes into 128 64 times. 64 plus 64 is 128. Well, this should be easier. What times what is 64? We know it's not prime. We know 2 works, but most people know that 8 would work. 8 times 8 is 64. What times what is 8? Well, we know 2 will work again. So 2 times 4 will work. We'll repeat that over here. 2 times 4. And then 4 can be broken down into 2 times 2. And we have this 4, which can be broken down into 2 times 2. So all the reds represent the prime factors. We've come to the bottom of the tree. So there are only 2's here. And let's see how many, let's count them up. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 2's. So let's write that. So we have 256 equals 2 times itself 8 times. 1, 2, 3, 4, 5, 6, 7, 8 of them. Now let's look at 538. We'll encroach into part C here a little bit. So 538, we know 2 is a factor because 538 is even. So 2 is one factor. And if you divide, stop the video and divide 2 into 538, you'll see the other factor is 269. So let's write that temporarily over here. So 538 is 2 times 269. So we see we can cross out the 2's. Now the only thing left, the only prime factors on the top are 2. And we know there's no 2 in 269 because it's odd. So it's impossible for anything to cancel out any further. So let's just figure out then what we have on the top. We see we have 2 times something. Well, we know the 2 will be 128. So we'll have left on the top 128, the bottom 269, and that is our final answer. So this last problem, part B, may have been a little more difficult for you, but don't let it overly discourage you, because if you understand the other parts or the other reducing problems, then this one seems a little more challenging for you. You don't want one of them to undo your confidence in the other, so keep that in mind. Part C asks you to reduce 340 over 850. Whenever you see a fraction in which numerator and denominator end in one or more zeros, you want to cross them out, because that's very easy, and a very easy way to make the size of both the numerator and denominator smaller. So you can cross out every pair of zeros that you find at the end of the numerator and the denominator. Here we find one such pair, so we'll cross out the 0 in the numerator, 0 in the denominator, and you'll be left with 34 over 85. Now the question is, can that be further reduced? Well, you know 34 has a factor of 2. And if you divide 2 into 34, you'll see that the other factor is 17. So 2 times 17 equals 34. I can show you quickly here. 2 into 34, 2 into 3, 1. 1 times 2 is 2. Subtract 1, bring down the 4. 2 into 14 is 7, and there's no remainder. Now, the only way this fraction can be reduced is if something in the top crosses out with something in the bottom. Now 2 is prime, and 17 is also prime. There's no factor that goes into 17 other than 1 in itself. You can try that to see that that's true. So the only way it can be reduced is if we have 2 in the denominator. Well, there's no 2 in 85 because 85 is odd. So the only question is, does 17 go into 85? And if you do a long division here, you'll see that 17 does go into 85, and it goes 5 times. 5 times 7 is 35, carry 3, 5 times 1 is 5, plus 3 is 8. So we get 17 in the bottom, and 5, 17 times 5. So the 17s are going to cross out, and the final answer is going to be 2 over 5.